In this video, we explore third degree, or in other words, group price discrimination. This is where a firm divides its customers into two or more groups and sets a different price for each group. Examples are airlines charging higher prices for business travelers, student discounts, senior citizen discounts, and coupons. An international business may charge different prices in different countries. In each of these examples, the groups differ in their willingness to pay, or in other words, the groups differ in their price elasticity of demand. In each group, the more elastic group, or in other words, the group that is more price sensitive, receives the discount. Here we can see that group 1 is the more elastic group and thus receives the lower price. The less elastic group, group 2, is not as price sensitive, so the profit maximizing firm will increase the price in group 2. You can see that in each group, the firm will find the profit maximizing level of output where marginal revenue equals marginal cost, and then use the demand curve to determine the price to charge, just like in the single price monopoly problem. Except now the firm with the market power solves the single price monopoly problem in two different market segments. When the firm with market power charges different prices to different groups that have different demand elasticities, its profit will be higher than if it charged the same price to all consumers, like in the single price monopoly problem. As we discussed in the previous video, to be able to engage in price discrimination, the following three conditions must be met. First, the firm must have market power. If the firm has market power, it can raise its price without losing all of its customers. Second, the firm must be able to identify different groups of consumers that have different demand curves, and must be able to identify how the demand curves differ. Finally, the firm must be able to prevent resale. If the firm cannot prevent resale, then those that are able to get the product for a low price will pursue profit by selling to those with a higher willingness to pay in a secondary market. Such arbitrage will bring about a single prevailing price in the market. Consider the following problem. A monopoly sells in the US and Japan. The American inverse demand curve is P equals 100 minus Q, and the inverse demand for Japan is P equals 80 minus 2Q. Marginal cost equals 20, regardless of where the final product is sold. What quantity should the firm sell in each nation? What price should it charge in each nation? First, let's solve the problem for the American market. Recall that the marginal revenue curve has the same intercept as the inverse demand curve, but is twice as steep. Setting marginal revenue equal to marginal cost and solving gives us a quantity of 40. Plugging the quantity into the inverse demand equation gives us a price of 60. Now let's solve the problem for the Japanese market. The marginal revenue curve once again has the same intercept as inverse demand, but is twice as steep. Setting marginal revenue equal to marginal cost and solving yields a quantity of 15. Plugging this quantity into the inverse demand equation gives us a price of 50. So we see that the Japanese market gets the price discount. Sometimes foreign nations claim that if a U.S. company charges a lower price outside of the U.S., then the U.S. company must be involved in an anti-competitive practice where it is trying to hurt foreign competitors by charging such a low price. However, it might simply be that the foreign consumers are more price sensitive, and thus the company will not charge consumers in every nation the same price if it wants to maximize profit. Since the Japanese market got the price discount, it must be that the Japanese consumers' demand is more elastic. Let's verify. First, let's find the price elasticity of demand for the American market. To do this, we need to first rearrange the inverse demand function to find the demand function by solving for Q. After we do this, the slope coefficient on P is the change in Q over the change in P in the price elasticity of demand equation. Plugging in the values for price and quantity that we solved for before gives us a price elasticity of demand of negative 1.5. Now let's do the elasticity calculations for the Japanese market. Solving for the inverse demand function for Q gives us a demand function with negative 0.5 as the slope coefficient on P. This is the change in Q over the change in P in the elasticity of demand equation. Using the price and quantity solved for earlier, we get that the price elasticity of demand in the Japanese market is negative 1.67. So we find that the price elasticity of demand in the Japanese market is more elastic, so the Japanese market will get the price discount. Notice that even though one market is more elastic than the other, The price elasticity of demand is elastic in both markets, which is what we would expect. Recall that in the single price monopoly videos, we learned that a firm always prices in the elastic portion of the demand curve. This is true when a company is pricing differently for different groups or different market segments. In each group, the price elasticity of demand should be elastic or it is not maximizing profit. If a firm discovers that for one group the demand is inelastic, it needs to start increasing price for this group if it wants to maximize profit. The Lerner Index can be used to find the price markup above marginal cost in each market segment or group if the firm knows the elasticity of demand for each group. The Lerner Index is powerful because often in real-world business problems, we can figure out the price elasticity of demand for a firm's product in different market segments or groups. Let's go ahead and work a problem. Tony's Pizza discovers that the elasticity of demand among college students is -2, while the elasticity of demand among non-college students is -1.5. Marginal cost is constant at $5 a pizza. If elasticity of demand is constant and Tony wants to maximize profit, how much should he charge for a pizza? When we plug the price elasticity of demand for the student market segment and the marginal cost into the Lerner Index equation, we find that in the student market, the profit maximizing price should be $10. When we plug the price elasticity of demand for the non-student market segment and the marginal cost into the Lerner Index equation, we find that in the non-student market segment, the profit maximizing price would be $15. Notice that the student market was most elastic and that the most elastic market segment got the price discount. The students are more price sensitive, so when Tony maximizes profit, he gives the discount to the most price responsive group, which is the students.